My name is Richard Ames. As usual, I've left my badge on the top of my dresser at home, so
We don't need your badge.
that's the way it goes, yes. Very casual presentation. It's mostly, the prepared presentation is mostly around side-scanning sonar. But I'm happy to talk about anything that you want to talk about from sort of a submariner's experience in the U.S. Navy. The slide on the screen was the last slide I had on the screen when I gave a presentation on inertial navigation some time ago, maybe a couple of years ago. So today I'm going to talk about side-scanning sonar, and the sort of nice little pictures are from a brochure by a company called Klein Associates, and it's the first side-scanning sonar that a group I led used starting in about 1979. And we used it for mostly small jobs, up to a depth of about 1,000 feet or thereabouts, so 300 meters. But we dragged this little thing all over the world to look for things that the Navy loses on the bottom of the ocean. Mainly airplanes, helicopters, and anchors. But which was a lot of fun. We went as far east as Italy and as far west as Oman, starting from San Diego, which is where we were based. That's a little bit about me. The important point was I was in the Navy for 20 years, supposedly in the submarine service, which I was all that time, but I spent very little time actually on submarines. I probably spent a total of 5 years on submarines, but 2.5 years of that was in the shipyard, making sure the yardbirds didn't sink it next to the pier, which they've been known to do. In Mare Island Naval Shipyard up in Northern California, one year they had 2 ship fitting gangs at opposite ends of the submarine, and they wanted to trim the boats to make it easy to install stuff that was supposed to be level, right? So they both ends of the submarine, the crew were putting in more water. Well, they put in more water until the water came in the hatches, and the thing sank right next to the pier.
You're kidding.
I'm not kidding. Absolutely serious. They had electrical cables through the hatches about this big, so they couldn't close the hatches, and down she went. So you know where the money in defense goes. It goes in big lumps. Okay, a side-scanning sonar is just like a side-scanning radar. Basically, you tow it through the water, somewhere close to the height above the bottom of the thing you're looking for. It sends pulses out sideways and receives them back in, and you get an echo off the bottom that's different when something's sticking up. So usually you're looking for something that is probably not normal to the bottom that you're over, like an airplane or an anchor or something else. And what you really see is the shadow that's behind the thing that reflects the sonar energy. And that shows you the picture right there. And the next picture is in the days when we were using the Klein side-scanning sonar, the recording was on a wet paper recorder. And basically it burnt an arc through the paper. And this particular picture is of a pipeline. And this whole sort of system was really perfected in the 70s by the oil field service people. And they needed to know where pipes were and where they were going to cross one pipe with another pipe and all of that stuff.
So where's the pipeline in the picture? Is that a white line?
In this particular picture, the center underneath the towfish is here, and this is rubbish off on the other side, and this is a pipeline here. That's the base of a platform, an oil well digging, an oil well platform, and this bunch of notes which I can't read. So that's just an example. So shallow water work with these things pretty easy because you basically drag it behind you. You have to navigate yourself within the area. I'll talk a little bit later about how important it is to have some idea where you are. But basically, you assume that you're going to be searching a rectangle generally or a square, and first thing you do is you assume the earth's flat because, for all intents and purposes, in your local area it is. So it simplifies the geometry. You tow the thing behind you. You make some assumptions about how far behind the towing ship it is, and when you find something of interest, and you want to know more accurately where it is, you essentially reverse course over it and split the difference and then come at it from 90 degrees and get a fairly accurate idea of where it is. Now, starting in the late 90s, the Navy bought this thing, which was designed to do the same thing, but down to 20,000 feet. Which is a whole different ballgame. And it was called Surface Towed Search System. And you, in theory, could search 95% of the ocean. And so we had this thing, and it was built by Westinghouse and 100% a custom job. The upper left picture is the towfish being lowered over the back of a ship. And the two pictures below that, it's being twisted so that it's in towing position, and then you basically pay out the cable. But the crane that it's towed on is motion compensated, which makes things considerably more complicated, because what you don't want is the ship's motion going up and down, jerking the cable every time the ship goes up and down. So they're attempting with accelerometers on the back of that thing to detect the ship going up and down and pan the crane down and up to compensate for the ship. With 30,000 feet of fairly significant tow cable, there's a hell of a lot of weight on the other end of it. And the hydraulics on this monster were quite something. I have here a picture of it that you can hand around, and I'll talk a little bit about it as we go. This is what it was designed to do, find things on the bottom of the ocean. And this is the example of a submarine that was sunk on purpose off the coast of San Diego. And these are, sonar images and pictures taken by that towfish. That towfish had a camera, 35 millimeter camera in it with 1,000 exposures, big roll of film, down-looking TV camera, forward-looking sonar to try and prevent running into things, side-scanning sonar to look out the side, and on the top, a transponder interrogator so you could navigate the thing inside a field of transponders. Transponders were basically things that floated off the bottom on a weight. You'd launch a whole bunch of these things around the area that you were going to be searching. Then you'd drive the ship around and survey the field of transponders. And then you could drive this towfish through the field of transponders and navigate in relation to it. The whole point of that being that if you ever found what you were looking for, you then knew where it was.
Richard, the transponders, are they a radio device or what?
Transponder sonar devices. Okay, so the surface ship or the towfish would ping, and they'd all ping in reply.
Right.
Okay. Now, one of the reasons that they built that thing was, this was all about espionage. Can't remember, in the early 70s, the Russians lost a submarine in the middle of the Pacific, roughly where all those circles intersect. And
Project Jennifer.
I can't remember the name. It's coming up on Project Azorian. And the U.S. Navy heard the submarine break up on what a sonar system called SOSUS. And they said, that's interesting. What are we going to do about that? And it was another multi-billion-dollar boondoggle. The intelligence community in the United States decided we gotta go get this submarine because it might have some intelligence value. The U.S. Navy said, not worth the trouble. We already know about this submarine. So there's a big argument in Washington, you can imagine, and the CIA won the argument, and Project Azorian was the result. And they built a ship to go get this submarine. They searched for it using another submarine, the USS Halibut, and they found the wreck of the Russian submarine. And then they went to get it. And that's the ship they built. It's purpose-built by Hughes Industries. Made to look like an oil field drilling ship, but that wasn't its purpose. And I suspect partly because of the argument about whether it was worth the effort or not, somebody leaked the damn thing, and it appeared on the front page of the New York Times in 1975, which kind of, you know. And the story has been, and still is as far as I know, that they dropped it. They picked the submarine up, got it to the surface, and then dropped it. Okay.
You know they have a thing on History Channel, about that.
No, I haven't seen anything about it.
They'll repeat it again sometime.
The hardest part of getting something out of the ocean is getting it out of the surface of the water, because the weight increases enormously as soon as you lose the buoyancy of the water. And number two, it's almost all, you can't do it in a calm manner. You know, you basically get it to the surface and then you try and snatch it, you know, from the water to out of the water, so you're not getting beat about. And so it's conceivable that they did drop. Anyway, the story was they dropped it. So I've got a whole series of sea stories. This one comes from sea story number one. Roughly 1983, we got a call and they said, we want you to go find an anchor. And we said, sure, that's what we do. So anyway, off we roared to just off the coast of Oman, which is all the way up there. Right about here. There's an island up there called Nasir Island, and the U.S. government had permission to land airplanes there once a week during daylight as long as they left before dark. And so anyway, we went from San Diego, California, with a bunch of air freight and so on and so forth, landed on this island, got ferried out to a search boat, found the anchor. Easy, not a problem. I figure our part of the job probably costs $100,000.
I could have sold you an anchor cheaper than that.
Pardon?
Not this sort of anchor.
It's a big anchor.
It's a big anchor.
It's a real anchor.
They then got the salvage people. You know, we helped the salvage people then hook onto the anchor, and they hooked onto it. And they pulled the anchor. Well, they pulled all the chain up on the top of the barge. And they couldn't, anchor was too heavy to get up on the barge, so they left it hanging off the end. Right? Then they towed the barge to Norfolk, Virginia. Okay?
With the anchor at the bottom.
And then they gave the anchor back to the aircraft carrier it belonged to. And the Navy said, thank you very much, and everybody was happy. And lots of people said to me, Jesus Christ, is it worth it? You know, I suspect the job cost about $300,000 by the time they hired the boats and, you know, towed this and that and so on and so forth. And the Naval Sea people said to me, he says, one of those anchors in that chain, you wouldn't get any change out of $1 million. Okay? So well worth it. Yeah. Okay. Next job. Next sea story. You remember the pictures in the Iraqi war with the missiles going through the windows? You know, the cruise missiles going through the windows? Well, those missiles were called Tomahawks. But back in the very early 80s, we didn't call them Tomahawks, we called them Tomarocks, because they were shooting them out of submarines off San Diego, and about 50% of the time they didn't do what they were supposed to do. What they were supposed to do was get out of the water, fly a little way, turn the engine off, fall in the water, blow the water out of the nose so the thing is sticking up like this with a great big orange nose and a hammer on the side of the thing that went bang, bang, bang. So all you had to do is stick a little sonar in the water and you say, oh, it's over there, and go get it, right? We got the job 3 or 4 times to go find my Tomahawk because it didn't shut off. And we'd always say to the boss, you know, where was it? And the admiral would say, I don't know where it is, but find it. And this is sort of a prelude to the story. You can't find something if you don't know where to look, okay? And we'd say to the experts, well, where was it when you last saw it? And they said, wow, it was just in front of the submarine. It was going northwest at about 300 knots. and we say, well, when do you think it stopped? And they'd sort of shrug their shoulders and say, well, it was supposed to stop there, but it didn't. Anyway, we never found one, ever, okay? We'd spend weeks, you know, up there going, yeah. So, and we'd end up in the corner with our face, you know, in disgrace. Another sea story, same thing. Spent 3 weeks off Charleston, South Carolina, looking for an F-16. They wanted the F-16 because one guy got shot out of the F-16. He survived. And one guy went in the drink with it. And what was supposed to happen was both the people were supposed to come out one after the other. If I remember rightly, the aft guy goes out first and the front guy goes out second. Anyway, that didn't happen. So we're off, you know, hurry up, get out there, find this airplane. So we went out there and we went back and forth for weeks. And finally, on the, you know, radio, talking with people, I finally convinced them to beat on the FAA's door until they got the transponder readings from this particular aircraft. And they gave us 3 latitudes and longitudes and altitude, and we got out our piece of graph paper and we said, well, it was obviously going in a downward spiral. It ought to be over there. Went and looked there, and there it was. Okay. But it's a great illustration that you can't find it unless you know what you're looking for. Because when you don't know where you are, where you're looking, the first thing you got to do is expand your search scale, which means you got much less resolution, okay, much less ability to see it. This particular airplane hit the water so hard that there was nothing on the bottom that was recognizable as an airplane. It looked like a little pattern of rocks, okay? And because it was in the Gulf Stream, the rocks were spread out in a fan. And we looked at that and we said, no, that ain't normal, okay? And we happened to be on a minesweeper, and the captain of the minesweeper said, well, how are we going to verify that this thing that looks unnormal is what we're looking for? And he scratched his head, and we all scratched his head, and he got his ship fitter, and he said, rig me something that'll will snare a bit of rubbish. So we ended up with a crankshaft out of an engine on the front end of a cargo net with a wooden frame around the back of it, and we towed that through the field of rubbish and came up with an airplane wheel strut. which we took back to Charleston and said, that's where it's at. Anyway.
What's the acronym there? Verified by...
Towed Underwater Recovery Device, TURD. Okay, the most recent big deal with side scanning sonar that I know of was the search for the Sydney. And there was years and years of conjecture about where the Sydney might be. And nobody did a decent job of working out the history until quite recently. I can't remember what year it was they found it, but it was like 3 years ago, wasn't it? Well, some search expert, whose name I don't remember, took it on and said, we now have side scanning sonar that's good enough to do this job, and if we get serious about the history, we might be able to find it. And he very quickly figured out that the state of the history was that they had a reasonably good idea of where the raider was, the ship that sunk the Sydney. And if they could find it, then they could probably find the Sydney in relation to it. And he did a hell of a lot of historical research, but the little brown square is where he came, is the end of his, all those dots are where people thought it might be. Okay? And it turned out that the captain of the raider, the German captain of the raider, had been imprisoned, and he had written a diary in a Bible, in code, in prison. And that Bible had survived until today. And this guy who did the history, he did most of his historical research in Germany to figure out where to go look. And so this is a very modern sonar that he used. That's a picture of the raider, I think. Yeah, the cormorant, the raider. And he found that in only 64 hours of actual searching time. Now keep in mind that, there's a vast amount of money in sort of setting these things up. But in my view, the most important part is the research. That's a picture of the Sydney. Now, all of this stuff these days is done on video monitors, and, the days of wet paper are gone forever. And that surface to search system, the big one we used, it was on black and white TV monitors. Now, this is another thing we did in the unmanned vehicles detachment. We had, remotely operated vehicles, and that's the end of it. So we used remotely operated vehicles. Now, I brought a couple of mementos. If you want to know about that sort of espionage stuff, this is a great book. I was also involved in a satellite program. That's a satellite. If you've never seen the full-size picture of the satellite, that's an interesting one.
What was the satellite, Richard? What was it?
That's a fleet communications satellite called FleetSat. And my involvement in it was, this is a book on it, tell you all about it, was an EHF package that was bolted onto the back end of it to an experimental thing done by Massachusetts Institute of Technology, and the details are in here.
That's EAH.
Okay. And that's about it. Any questions you'd like to talk about? Submarines and all that stuff? You.
How did you get the submarine up off the bottom at the wharf, Rich?
Oh, how did Glomar Explorer did it?
No, the one that sank at the wharf.
Oh, hell, I don't know. He was only in 30 feet of water, you know. It just,
That's enough, though.
I'm sure they cut the cables out of the hatches, closed the hatches, and then pumped it full of air. Okay?
That Omar Explorer, they towed it all the way through, suspended underneath what was left of the, only got out the conning tower, and they got it all the way back and put it to shallow water before they put it.
It depends which book you read.
Well, this is History Channel.
The way they raised the Kursk, which was the Russian one that went down up near Murmansk, they put slings, they maneuvered slings underneath it, you know, dug into the mud, because it was only in 300 feet of water, you know, easily done by divers. They shoved slings underneath it.
I don't think it was slings.
Hmm?
I think they put bolts into the top of it.
Isn't it, Barry?
No, I don't think so. Anyway, we can check. And then floated it with barges. So we went out to dinner last night with a guy who's works in defense procurement here, you know, and chatting about Australian submarines. And, you know, I think they have 6 Collins-class submarines, only 2 of which they can keep at sea, and they got a whole shitload of troubles. One of the big ones is they're having trouble crewing them. You know, they can't get people.
They can fit 4 out, but they can't crew them at the moment.
Yeah.
It's a volunteer service. Not enough volunteers.
Yeah. And, you know, it's, you know, I think a real problem.
There was a good ABC series on the Collins class and actually crewing it. And they joined some exercises and they actually got past a few of the American subs and various other sub-finders, which I thought was quite remarkable. So a friend of mine's in the service and I asked him about it and he said the thing was so noisy that the Americans didn't believe that it could be a submarine. So they basically ignored it. Because this thing in the show was brilliant. It snuck straight past everyone. And
yeah, my personal view is I don't understand how they rationalize a conventional submarine these days. You know, the nuclear power has so many advantages.
This is Australia. So
Yeah, and so you're caught in that political squeeze.
we got all the fuel, but no anything to use.
So,
Well, we used the US Navy to lower the noise, which was mainly propeller noise, I think. There was some deal done because it was made by the Swedes, or designed by the Swedes, so there had to be some security thing about the Swedes not finding out what the propeller looked like.
Yeah, right.
The Yanks, actually. So the other way around. Not allowing the Yanks to see what the propeller looked like, but we took it over there to...
Well, the US Navy redesigned the propeller, I think. That's what it was. Don't use the US Navy to quiet that. That was the trouble. Cavitation was.
now, one of the things I'm interested in these days is Wikipedia, and the newest Wikimedia Foundation project is WikiVoyage, and so it's if anybody's familiar with WikiTravel, WikiTravel's essentially a commercialized travel site, and what happened was the people that were working on WikiTravel got the shits with the commercial arm of it, and I think a significant number of them sort of jumped ship and went over and petitioned the Wikimedia Foundation to host them, which was all agreed and so on and so forth, and they essentially renamed it WikiVoyage. It's wide open for people to improve it if you're interested in travel stuff and interested in writing up, you know, what you think about various and sundry places. So, yeah, so on and so forth. Okay, any questions?
Yeah, is the side-looking radar essentially a Doppler radar? I remember doing the theory, but I can't remember it now.
No, it's not Doppler. It's just ping, ping, ping. Okay. There are Doppler sonars, and the forward-looking sonar was a Doppler thing.
Right.
But I don't think they use Doppler in the side scanning. Okay, because you're from the point of view of your side projection, you're basically motionless.
Yeah.
Okay, and the things you're looking for are not going to be moving. So I wouldn't see much point in the Doppler part of it.
Not if it's going straight out.
Yeah. Good.
So, with sonar, what's the typical frequency of the ping?
That's a hard question. I haven't a clue.
Okay. Approximately. In the kilohertz or?
Yeah, 14 kilohertz, but I'm not.
It's acoustic, isn't it?
Oh yeah, it's definitely acoustic.
Yeah.
Bit higher than you'd think, but I don't really remember. You can certainly hear, an active pinging sonar. I've heard them in a bloody submarine, with ping, ping, ping. But the side scanning sonar, I think, were higher. You certainly couldn't hear it.
And it goes out in all directions, and then they listen for the.
Oh no, it's quite focused. The side
Very
scanning
focused,
sonar is
is it?
quite focused.
Okay.
Fairly long. Well, the big towfish, the thing would have been sort of 6 feet long. The transducer array,
It's right along the length of it.
right along the length of
And
it.
it points out.
Yeah, and the smaller one, the transducer array would be about like
Okay.
that.
So the energy goes out.
Yeah.
Laterally.
Yeah.
With about the width of the actual toe device.
And
I'm guessing if you're towing this thing at 10,000 foot depth, that periodically you bang into something and do a lot of damage.
it's a problem. The other huge problem is that in order to tow something at great depth, with the towfish is way behind you, and if you're going to do any kind of a sensible job, you have to go very slowly, because the minute you speed up on the surface, you pull the towfish off the bottom. So that means if you're towing something deep, and we had this problem, you have to go really slow.
Slow, what's that, 5 knots?
And slow like 1 knot.
1 knot, okay.
And if you have any kind of weather, then controlling your heading gets very difficult. And, that's another sea story. We used to rent an oil field service boat at $3,600 a day, right, that we used to run around off San Diego. And there's no way this thing would maintain any heading in any kind of wind, because it was big, flat, about 150 feet long, big superstructure on the front, and as soon as the wind blew, off it went, right? So if you were going 5 knots, no problem. But if you're going 1 knot, you just couldn't control it. And so we got in great strife because we couldn't control this damn thing. So searching wasn't working. And I ended up in front of the Commodore, and he said, well, what's the hell's your problem? And I said, well, we can't control our steerage, our track, because it blows off course. And he said, well, I thought it had 2 screws. And I said, well, yeah, it has 2 screws, but don't make any difference. And he turned around to the supply guy and he said, I thought we rented something that was supposed to do this. And the supply guy said, yeah, we did. It says so in the contract. And the Commodore looked at the supply guy and said, fix it. The supply guy called up the MSC, with the people who had hired the boat, and said, fix it. And the MSC called the owner up and said, have you looked at the contract? And the owner said, yeah, we've got it. And the MSC guy said, well, it says in the contract, if you don't perform as specified in the contract, number 1, we stop paying. Number 2, you have to fix it. And then we'll start paying again. Well, fortunately, I left.
That never happened, right?
Well, no, they took it, it went off hire, It went into the shipyard. They put an absolutely humongous bow thruster in it. Right? You know, a thing like this.
They're only designed to run for a few seconds, though.
Oh, yeah. And
Puro's dog.
I went to sea on it a couple of times after that. And you run that bow thruster full bore. You couldn't hear yourself think in the front of the ship. And it didn't make any difference. But fortunately, I didn't have to show up in front of the Commodore and tell him that. Anyway, that's about it. It was a great thing to do for 20 years. One of the major problems in the United States government these days is the spending is absolutely out of control. Okay? They cannot afford to keep doing what they've been doing. You know, when I was in the Navy, we had essentially an infinite amount of money in all the places I worked. And it was just crazy stuff. You know, big boys and their toys, it was great fun. But from a fiscal point of view, it's just crazy stuff. Okay? And, you know, I think the chickens are coming home to roost.
You never thought of doing that sort of work once you got out of the service?
Pardon?
You never thought of doing that sort of work once you left the service?
No. I don't want to go to sea. Yeah. No, I migrated to Australia. And the first people I interviewed, which was AWA, and they were interested in me working for them because, you know, I knew a lot about transponders and all that kind of stuff. But we quickly figured out that me getting a security clearance in the Australian government wasn't going to be easy because I wasn't a citizen at the time, et cetera, et cetera, et cetera. In spite of the fact that I had all kinds of U.S. clearances, getting clearance in Australia wasn't going to work. And at the time, I went down to the AWA facility that was on Ryde Road, just across from where McDonald's is now. And I walked up and down the halls, and I said, Jesus, this place is full of cobwebs. Yeah. And I really just didn't want to do it. I ended up working for Digital Equipment Corporation, which went out of business in '94. But they paid me out in '92, which was quite convenient. Yeah. Good. Any other submarine questions? Living on a U.S. submarine is quite nice. You know, unlimited water, unlimited, you know, this and that and the other thing. Plenty of room, big submarines. Yeah.
Yeah, that was on the boomer, wasn't it?
I was on boomers, yeah. And 2 crews per submarine, which is part of the solution to crewing submarines. You know, going to sea forever, particularly, you know, join the Navy and see the world?
Not in the sub.
Not on a submarine, that's bullshit, right? You go out of your port, you get to the 100 fathom curve, you go, and you don't see anything until you come back to the 100 fathom curve. Okay? So, you know, if you're doing that on a, you know, month in and month out, I don't think it's going to work. But if you have 2 crews, which is what we did on the boomers, you're 3 months at home, 3 months on the submarine. You know, just, you know, turn your hat around. Away you go. Pretty.
And would they fly you to the next location?
Yeah, in the day I was doing it, the submarines were forward based. Holylock, Scotland, Rota, Spain, and Guam. And I only ever operated out of Spain or Holylock. But we'd fly to the submarine, have a 4-day, 5-day turnover with the crew we were relieving. Okay. They'd fly back, you know, worked like a charm. Okay.
So
of course, it's
a handover, did you?
Yeah, expensive.
The switch on the left a bit icky. Be careful of that.
Yeah. Well, no, we had 25 days to fix all of those things that they said are screwed up, and a submarine tender beside us with, you know, all the facilities to fix things. so on and so forth. You know, so they'd come back with a list of everything that was in any way shaky, give us the list, pack up all their paperwork, you know, so on and so forth. One of the things that in the navigation business, inertial navigation, and with the purpose of which was to support the missile system, i.e. get the missile on the target. One of the really great things that most people don't know about is at the end of every patrol, we send a box of top secret paper and computer disks and so on and so forth to the Johns Hopkins University's Applied Physics Lab. And they took the thing apart and they analyzed everything that happened in the previous 2 months with the navigation system. And roughly 2 months after that, they'd come up to our offices in New London, Connecticut, and they'd say, you know, we've analyzed the package and, you know, we thought you did a reasonable job of this, that, and the other thing, and it all, you know, generally it looked pretty good. But they'd then say, you know, on September 23rd, you reset inertial navigator number 2. Why did you do that? Okay? So if they thought you made a mistake in the way you operated the system or anything like that, they'd go through it. It was an absolutely fabulous training opportunity because you'd have a bunch of physicists and electrical engineers and everybody involved, you know, that took the thing apart. And with the benefit of hindsight, they could say, hey, you know, if it had happened this way, you know, so on and so forth. And
would you modify your procedures accordingly? Is that the result?
Well, that was mostly done as an educational thing. But of course, they modified the whole program when they discovered something. Like they very quickly figured out that the Earth was not homogeneous. So the local gravity shifted all the time. You know, so particularly when you drive through something like the Straits of Gibraltar or over the Marianas Trench, the inertial navigators used to go snake ship, okay, because down moves, okay, because the mass of the Earth is unevenly distributed. As soon as they figured that out, which happened pretty quick in the 60s, they started mapping that. And they used, you know, when they saw an unreasonable perturbation of the inertial navigator, they feed all that data in and started mapping the, you know, the gravity vectors. And in the early 70s, when they came up with the next iteration of the thing, on the second submarine I was on, we had bigger central computers, and they came with big reels of tape that contained all that local gravity vector. So what they would do was torque the inertial navigator to correct for it. Okay.
What class of sub was that, Richard?
The second one was Benjamin Franklin, 640 class. And the first summer I was on was Sam Houston, 609. So, and the inertial navigators got wildly better in the 5 years I was involved. On the Benjamin Franklin second submarine I was on, we left port in Charleston, South Carolina, and returned to port in Rota, Spain, 2 months later without resetting the inertial navigator at all. Okay, which means less than 100-foot error at the end of 2 months. Yeah. And that was in the early 70s. And they're a hell of a lot better these days. So.
Thank you.
Thanks for your attention.